Now, in truth and in fact, if they ask us to determine the size of the angle YXZ, assuming that it's not a misprint, what's the size of the angle YXZ? It is. So we don't assume it's a misprint. What we could do in the exam, we could say, give them what they ask for. They ask for the angle of YXZ. So we write YXZ. We don't give them too much more information. We say YXZ, that's what they asked us for. YXZ, 125. Just put in your 125. Assuming that it's not a misprint. And sometimes as a student you can ask in the exam room, you can ask the examiner, the person who's administering the exam, to clarify. And if they do clarify that it is in fact YXZ, your answer is 125. Alright? And don't assume, again, don't assume anything, answer the question that they ask. They ask for to determine the angle, it says the angle YXZ, you give them 125 as your answer. Now you could put that XZY, in the case that it might have been a misprint, XZY is equal to 20. But you could put that as part of your working. So you show your diagram, show your working, and at the end, YXZ is 125, which is what they asked for. However, part of your working is to show that XZY is 20 degrees. And the examiner will give you that wrong. But your answer to the question is based on what they asked, maybe after you verify with the examiner. What's the size of the angle YXZ? The size of the angle is 125 degrees. Right? And there are three parts to the question. So what's the third part of the question?
Calculate the nearest whole number of the distance YZ given that YX is 100.
Okay. So YX, the distance, the size of YX is 100. So we put 100 here. YX is 100. And they're asking us to calculate what exactly? YZ, which is from Y to Z, which is this long side of the triangle. So, how do we calculate that? Well, difficulty in questions like this, as we have already done, it's sometimes helpful to identify where the right angles are, and we've already done that. And we discussed how we arrived at that. We discussed how we know that the bearing of Z from Y is 0 degrees because it's due east. So we were able to construct our right angles here, constructing a perpendicular off of the line YZ that intersects X. We were able to rationalize the other angles, and we could then use the 100 length of YX with the 35-degree angle to find this piece. Yes? We are not saying here that there's sine, cosine, or tan, but we could use the 100 and this 35 angle to determine from here to there. We could also use what we also need to do in a second calculation is determine this distance here. We could call this intermediary point alpha. Okay, let's just call it A. This intermediary point here, we can call it A. So from Y to A plus from A to Z gives us the whole Y to Z. Yes? And we know we can find this distance within the 100 and the 35. If we find this distance from Y to A, we're not looking at the actual calculations yet. If we can find from Y to A, what do you think will be the next step in determining the distance of A to Z? Is there an intermediary step? Can we find it directly? Okay. What do we need? We need to find a length. And that's a perfect answer. In order to determine this, which is our end result, it would be helpful if we have either this length here or this length here. Yes? Because any one of the sides of a right angle triangle, right? Any one of the sides of a right angle triangle, and any one of the angles that is not a 90-degree angle, can allow us to determine the length of all the sides of a triangle. That's just something that we learn when we're working with angles. Once you have a right angle triangle, you know that there's a 90-degree angle, and any one of these lengths with any one of these other two angles will allow us to resolve all of the sides of the triangle. So we have the 100 and the 35. Can we use the 100 and the 35 to determine this length? Yes, we can. We are going to use the 100 and the 35 to determine this length. What are we going to use? Sine, tan, or cos? Cosine. Can't remember.